So we have one plate. These are top plates, they call them. We have one that's totally done. We'd welded these up, milled them back out. I tried to keep a little bit of the original surface there because I found the height on this is really inconsistent with the world. And I'd rather just keep it with what they had instead of what the sample new part was, because they're all over the place. They're moving by a couple millimeters. These ones here, besides this bushing is a thrust surface. This is a thrust surface. These two lower thrust surfaces are supposed to line up together. So I'm doing the best I can to pick up just where we're shaving the paint off and keeping the same place where it was. If we take a little more and it ends up slightly loose, it's better than tight to where they can't put it together. And then we'll put it in our fixture and bore ream, which I'll explain when I'm doing the bore reaming, what I mean by bore reaming. Because, well, I can explain it some now even, but normally the idea of reaming is you follow a hole. And when I say bore reaming, what we're doing is we have a reamer that goes inside of this drill bushing, so if the hole is off by 30 thousandths to one side, it doesn't matter. The reamer is guided by that drill bushing, so it will bore the hole in line with the bushing rather than being in line with the existing hole. And that's the kind of accuracy you need if you're going to use a reamer on these sort of things. You can't just drill a hole, throw a reamer through it, and say that it's going to all come out straight enough to work together. This one here, we're working on doing the sides. We've got these ones done right now. This right here, I can come in here and I can measure it, but my measurement is crooked. It says 71 thousandths more to go to there, and it feels like 60-ish, could be 70, but I'm not going to take 70 because I'd rather run over it a couple more times. So we are going to take, I'm going to go with 60. If it didn't feel like 60 something, then I might go 50 or whatever, but it pretty much felt like 60, so we're going to call her at 60. Now, it looked like, and it did, it cleaned up there. So since it cleaned up there, we're not going to take another cut. And the reason then, figuring that it looked like it was cleaning up there, I stayed at the bottom. So now I can come over and do conventional milling coming back up the other side. And my initial movement for that will be the drawing that I made off of their new part, which was 1.339. I've done this before, but we'll just do it again. 1.339 minus nope, is that the right one? Yeah, that's what it is, minus 0.75 because of our 3/4 inch end mill. Means I need to move, 589 to come up and get the other side. And since we did clean that, we'll probably be just shy on this side, and I'll have a 5 or 10 trim cut on this side. But we'll come over, what was that again? It's better to not make mistakes. They can subtract, what do they say? Subtract twice, cut once. and the wrong numbers, see? Minus, needs 0.75, not 75 inches. Yeah, 589, 589 big block. There we go, okay. That one was screaming enough, making enough noise. I decided it was a big enough cut. We still got, like we say here, 40 thousandths to go, 40 some. Good, feels like 40 or 50, just feeling it. We'll measure it too. It says I'm at 540 instead of my 89. But I wanted to stop and come up because it was squealing. It was making noise. Pretty heavy cut anyway. So when I did this last time, I used a 1/2 inch end mill in here. And this time I'm using a 3/4 inch. The 1/2 inch doesn't go down in these little slots. You can see these little slots they originally made down here, which I really can't tell if they're 3/8 or 10 millimeter, but either one would be close enough. And I don't dare go down and cut all of this out with the big end mill. I was going to swap these out after I did the first one with the small mill, and then I had to clean this up a little bit. But I see the 3/4 inch end mill and what's left. I think it'll be just as easy to clean this up rather than putting in a second mill and picking up the edge again. I think that'll be just fine doing it this way. The carbide end mills, I love carbide end mills. Pretty much the only thing I buy anymore. Had somebody in the comments the other day talking about how, oh, I forget what it was, something I did, and they said, oh, his end mill's not new, no big deal, they're cheap because, you know, job shops don't ever use carbide end mills. They do today. They didn't 30 years ago, 50 years ago. You know, when I first started in this, no, we didn't use carbide. You couldn't hardly buy them. Even though CNCs were out, you couldn't hardly buy a carbide end mill. It's the higher production of the CNC mills that have made the production numbers of the carbide end mills large enough, all of us buy them now. You know, they work. And if you're not buying them, buy a few. Try them. They are good. We'll go measure that. See how it compares with our 49 thousandths that we say we need to have according to our numbers. Again, we can only get in here at an angle. It says we got 71. 71, we figure we got 49. I will have no problem taking 50 without feeling scared about it. We gotta get back down close to the bottom. Okay. Somewhere about 7 thousandths, I would guess. So, yeah, we'll just try that. We could do another thing here too. We could come down with the cutter, and I did that on some and use a feeler gauge between here. But this is rough enough that it's sort of a guess when you get done anyway. I think we just cleaned off the paint, maybe a little more. I still feel there's just a little line between them, which should be, but we made clean metal all the way there, so that's enough. Slight amount more, it will fit. Too little, ain't going together, nobody's happy. Now, for this other side, which doesn't fit anything, the other side is just a matter of, I'm here in the machine, it's easier than grinding it. I'm gonna blow the chips off. Get your eyes out of the way there, Bert. Okay, so this one is actually 906, so I'm gonna come over 900 plus 750. 1650. Yeah, I'm gonna give it another cut. Just look better when we're done. just touching here. We touched a little bit there. Pretty close. Paint or a flapper wheel would pretty well take off the difference that you see. So we'll measure again. So we come back to the other side. And I want to go just a little bit long this time, so I know I got some to take off. Go 3.1 plus this one you should be able to do in your head. 385. 3-inch 850. So let's zero it. And yeah, that's right, I wanted to have a little more. Yeah, 880. That's good. I'll just zero it there again. I want to stop for a second to mention something, not that it matters, but this is not originally as deep as this here, but I'm making them the same depth now. It doesn't make any difference. Reason was, when they made this part, this outside step here and this off here, they made this block with these outsides milled, then they welded it on. So it originally is wherever on the outside, and then after they welded it on, then they milled the inside, and they came a little bit deeper than what they had here. And they probably had this inside cut out roughly to size so that they could use that 3/8 end mill, and they were 10 millimeter, whatever it was, and they probably had it on a CNC and just taking little cuts. They probably had this roughed out already to this depth here before they came in and did the final after it was welded on. Now that one we should be able to actually get in and measure it because we're straight onto it. There's nothing in our way. .74. Yeah, it's crooked. Not that it matters again. And the last one I did, when I did that, I came over and did my first part according to the dimensions on my drawings of their sample part, and it was off by almost 3/16 of an inch before I touched the part. So that's why I measured it this time to see where it was, so I'd come closer to where the part is. But, yeah, actually just what I wanted. But I didn't want that. That was the furthest I wanted to be. Because that's correct, that's done. If I had guessed a little bit more off, you get a little bit too gutty sometimes, then it would have been too deep and wouldn't have been as good. It's actually just right now. I was planning that I'd probably have to take another 5 thousandths or so squeak in on it, but we don't need to. Okay, so for our last side, again, where did I toss my calipers? I leave my calipers on that side? I probably did. Part of the problem of a big machine, bigger machines, more places to scatter stuff. Okay, and this one over here can be lower than the surface without being any problem. So if we call it 1 3/80, and no, I don't want to go that much because there's quite a bit of weld. I do want to take 2 cuts yet. So, and actually wider setting would make us have more to go. So I'm going to go 1.4 for starters. So 1.4. And we have to go plus 0.75, means I need to go 2 1/50. That really turns slow in the camera viewer. And these were the welds that I did with the copper backing that I was talking about recently. Okay, so we go this way, take another 30. Original suggestion that the customer was wanting was to, I don't have any that are unrepaired, but to just run a reamer through these and clean them out and make bigger bushings for them to make it all line up. But if the original holes were close enough to the same on every one and you had a good location to come off of so you could do that, you could do the same thing as we're doing with reestablishing these. You could have a bushing that guides the reamer and goes through, and then you could make oversized bushings. But the placement of these is moving 3 to 5 millimeters from one to another. It's too much. It's too much. We weld them up. That way we can drill it with a fixture and then ream it, and we know that the hole that we drill will clean up with the reamer we're using. If we just took what was there and tried to clean it up, you'd still end up welding them now and then. So you might as well weld them all. And the other thing with this is we don't have to make special bushings. Now they use their original bushings. So, yeah, we'll show, with the clamping here, this is a little bit interesting too. Our reference points are these keyways. The bottoms are not accurate. Sides are somewhat accurate, although the width on these, again, varies by 2 millimeters from the shortest to the widest. We kept them squared up, but they vary. But the keyways is the thing that I found to be the most accurate on these. So we put 2, 4, 6 blocks down here, 1, 2, 3 blocks up here, put them all on keys, clamped them down, and then to make sure, because if you see, you really don't have a whole lot holding them on the key that will keep it from moving around sideways. So we put this unfinished octagon gun barrel through there to use it. It's 4140 blank that was for octagon gun barrels. This one would not make a barrel. If you look on the other side where it has the red on it, that tells me that it's one of the ones, and we had several of them, that they had pre-cut the saw stock too small. So when it's already too small, before we did our finish milling, there was no point in carrying on forward. So this one was basically scrap and just to be used for other things. In fact, it's a big, long octagon barrel. We cut part of this off to make something else out of. So it's actually shorter than the barrel already too, which I picked it up and just right for a clamping bar. And that lets us hold it down. And when you're doing that, of course, it's rocking. And you clamp it here, it rocks on the other side. You got to kind of work each side because one will try and rock way up. You're really just getting the clamping only at the edges because the bar bows and bends a little bit. It works. You don't know how you're clamping a lot of this stuff down until you get there. So, our guide that we had put on there, and we've drilled the holes that were not drilled. The ones that were not drilled on this one were that one, and this one. We've already tapped that hole. We will come in and we'll show you tapping another hole here. I like radial drill presses, and I like them with power clamping. And if we were really tricking it out, because we were doing lots of production, we'd set it up to where we had both oil and water soluble on the machine. But we don't, so this is just what we do. I know, somebody out there was saying, I hope he breaks the tap, it'd be so good like that, blah, blah, blah. No, we don't do that here. They do that on the other channels, where they destroy a 1-inch tap to get, I couldn't believe it, 15 million views watching a 1-inch tap break, why? Hey, okay. I'm not gonna stoop that low though. So, we'll continue on. We got more things we're gonna do on these, but this, getting the threads done there, got a few to do on the other side, and before too long we'll mill these off and then we'll put it in our super fixture and do the final drilling and reaming, and it can fly away, go back to its home. So we're getting ready to, I'm putting this on here. I checked, my clearance is a little tighter in this middle slot than what I thought it was going to be. So that's my deciding slot. Now, I originally was figuring that I would set my gap by this for just a little clearance, but these are not consistent in thickness. Fortunately, the first one I had was a very thick one, the one I measured. So at least I had left enough room for it to where, but I really wanted to have it so that I was bringing this up tight so that you're closer for the reamer guiding. I did one already, it worked out okay. You can see down here on the other end where we are close here. So this is consistent from, which makes sense since both this surface here and this surface here are matching thrust surfaces. So you would think that they would keep those pretty consistent from one part to the next. This one is just an open end, and I was surprised to find out that it varies by a good 3/16 of an inch from one part to another. The holes in this part of the fixture, I haven't tightened these down yet. I left it where I could move it a little bit. These ones right here for variation right from the start, we figured we slotted those. And the keyways guide it, so I tap it back and forth to get my centering here where I want it. Once I've got this correct, the reamer block is pretty much the same. Made it to real accurate length dimensions matching this one, so if this one bolts on, unfortunately, this would be a nightmare to bolt on in the radial drill. Originally, I was thinking about setting this up with a second pad that went on here for a mag drill or something, and that would be good, but then you still got coolant to deal with flowing down, and the radial standing up works pretty good for that. And we'll see how this goes. It's been a longer project than I wanted it to be. This is the second one we'll be doing. We have 4 of these at the end here to do for the whole job. And we'll tighten that down. I don't know what I'm going to have exactly. It will go on the side of the drill table here. And we'll see in a little bit. I'll hang it with the crane and whether I'll have another angle plate over here. Last time I just C-clamped the first one to the table, didn't quite get it straight, a little more wobbling up above. It was okay, but I don't like it as well as doing it better. So we'll try and do, since we've got 4 of them. I knew the first one I did was going to do one, and then I had a whole bunch more work to do on these, so I wasn't like setting it up where I could just do all 5. Now I'm setting it up to do this one plus 3 more, so we'll get a little nicer setup on where it bolts on here. Okay, so we did use C-clamps again for this here, and I had thought about it a little bit. If I moved it over further, which would have made me short on the other side for my angle plate, I could have used a clamp onto this, but I really don't want this captured anyway. I want to take it off each time I reset one of these, as I was doing back on the bench. Just as a side note also, while I was doing this, I noticed my column on my drill press. Bottom part of it was real dirty, so I went in there to clean it up. I got multiple splinters. There are splinter days in a shop, which is just normal, and then there are days when you have so many of them, you can't wash your hands. It's just, you know what it is. You've been there. If you've been in this very long, you've been there. Not enough to make a short out of it, but just one of those little things that you get it now and then. If you don't work in this, it is a real thing, and because you can't see it because of the dirt. You got to clean it, but when you clean it, it pushes this, and you got more than one, so yeah. Anyway, had one of those earlier today. So here we are to this far side here. We're already lined up. We will push the start, and oops, forgot my coolant. Turn on my coolant. Very, very important to turn on coolant. Lots of coolant, but not on the cameraman. So we're drilling through this here and that there, then I'll change out to a longer drill bit. Wait a second. I didn't want to start on this. I forgot. And it got me befuddled where I moved my drill and everything. Right general idea except for one important step with this setup that I figured I needed. I want to put a jack underneath here. But too much load. The C-clamps there and this, it's going to want to push as we're drilling. It's going to want to move. So we need to put a setup jack underneath there. Not there, under here. Okay, this one's probably about right. Just to take the sideways push. Doesn't have to be too fancy, too accurate, just something out here to keep it from going down. And the bed is about as much as we can have for now. Now I feel okay. Did you notice how I checked the clutch being in neutral before I turned the motor on? Because it wasn't actually. I had gotten befuddled and had it not in neutral. That's part of our habit here, is to always check that stuff before we turn motor on. Now there's a second bushing. This bushing you can see here, there's also a bushing in here to guide for the second hole. Because this bushing up here, you'd be too far off by the time you came down to the next hole. So now we're starting through the second one. And then there's a bushing from the other end way at the end for this too. There's three bushings, one for each of the holes we're drilling. Ah, there's a problem. Chips will be underneath the bit maybe, but I still needed to clear it. That I didn't like. Okay, I got the problem there. It happens. We got to bring an air hose, blow that out. There's a chip skating around. If you leave them go too long, too many chips build up, you have the problem of, as we were starting to have there, of it binding sideways in the flutes. Doesn't clear out. But also on the end, you'll have chips that build up in there, and they'll end up sitting right under where you're trying to drill. So chip will be skidding right on the cutting edge. Chip will sit under there and keep riding around and skidding, and you take a lot of pressure and not get anything done. And sometimes it will eventually cut that chip in two, which is what I was trying to do at first, and then start in drilling again. Other times you got to clean it out. Sometimes if you wait too long also, those chips will weld onto the bit, and that's real ugly. But you can resharpen it. Life can go on. It's not the end of things. It's all just metal. Other than your fingers and hands, so don't get them in there. Okay. Now it started drilling right away. Much better. Okay, we're gonna just quit, blow it out again, because it is just being nasty. Now this, the chips would not be as much of a bother if we were going sideways, but we wouldn't have the advantage of the coolant being right in there at the cutting point. We want to micro-control gravity. Don't just want gravity change, we want to control it different in different areas. If we could. We can't, so we're not gonna. Okay, that one has gone through. Second point there. Okay. Now we need to go back up. No guarantee as far as alignment with the hole. They're supposed to, not always happens. Okay. Get a better place to do that at. Okay. And for the other one, we are doing drill check. Drill bit right there. Yep. Up some more. And if I remember right from last time I did this, after I went way up for this, I think I had to go back down also to get the drill where I wanted it, because there's only so much travel. We gotta go back down some too. Once again, don't buy Jacob's Chuck's used ones from Howie's machine shop. The main reason not to buy them is because he doesn't sell them anyway. Pretty well uses them up. And then after he uses them up, he uses them for parts. Yeah, okay. We're gonna do this lower hole down here, and I've fought with it a little bit, chips building up in there, trying to get underneath the bit, all the different things. And what seems to be working the best is if we run it for about 1/8 of an inch, disengage the feed, let it rotate a little bit, breaks the chips up, but don't really clean them out. Just stay there so we can go down again. Now, of course, the ideal thing would be if we had a coolant-fed drill bit with 1,000 PSI to it and we just blow the chips out. It's good. I'm all for the new stuff. It doesn't apply in every application for all the setup time, though. But it is cool when you can do it. And I was getting a little bit of drill bit wear, so actually I'm going to drop down one gear, too. Yep. Okay. We need coolant. Pretty solution, that's what it is. It's, yes, solution was the coolant we've been using here lately. I'm gonna go down a little more. Okay. And even with doing that, it's not quite enough to just let me keep going. So I do the whole halfway, clear out the chips, and we'll go at it again. And I can see why it's actually getting chips right near the top of the hole here. Top of the, right up there. Patience, patience, patience. I was told once that a good machinist could sit, watch a lawn, at the end of the day, tell you how much the grass grew. I don't think that applies to today's world in a lot of things where pick out numbers, push the print button. Although some of those take quite a few hours. One friend of mine that used to work here, worked here as a young kid, went down in the States. He was telling me about something he was working on that was like 60 or 80 hours per cut, and then they'd laser measure it all and had a couple thousandths left to go after that, deciding which ways to compensate for what it was going to be. I don't remember what it was for. I think it was some space shuttle, something or other. Nonetheless, it must not have been as exciting as some other things because he's working as a mechanic right now. Or maybe it didn't pay as well. I don't know. Spend enough money on machines and software, there's not a lot left for the employees. Sometimes. Now, another thing with this, if if I do a bunch more of these, I'm going to cut a second hole in here. I didn't want to at first. I wanted to leave the fixture as solid as possible to start with. Know that we had something good. And I was really concerned to make sure that all of our holes line up when we get done, because there's only a couple thousandths clearance between all of these holes with a ground pin that goes in them. And actually we can show you one of the finished ones here. I was going to do that later, but we'll just do it right now. So we've got a pin, and these are ones we've put the bushings in already, and that's part of what I told them at first, give me the bushings, and we would put the bushings in and make sure that it all worked good. Yeah, after doing 3 of these and next ones, they all go good, they can put their own bushings in next time. I just wanted to start out there to know that we were giving them a product that they wouldn't be coming back and saying, bushings didn't work. It's not right. Now I feel confident enough of our process that we could do that. The other thing I do, if we get more of these, this block here, it's going to get Swiss cheesed. It's going to get a bunch of holes. I want it to be lighter. I thought about doing that right off even because it was just sort of a nuisance to handle. But again, it's like, let's do the first 5. Let's get done. If I got to pick up 100 pounds, I have to pick up 100 pounds. And then we'll figure what to do next time. I mean, you go to the gym. What do? You pick up 100 pounds. Maybe a little more now and then. But somehow you don't want to do it at work. Keep yourself at 60 pounds, 70, whatever this magic limit is. It is easier to hurt yourself on the job, though, than it is in a nice structured environment at the gym.
Not isolated, yeah.
And that is why I have some problems now. I used to lift a little bit heavy. And then
You hurt yourself lifting?
That's complete 6.2 diesel engine. Didn't even have the injection pump and exhaust manifolds on it. But I got it back on a pallet. Picked it up, put it on a pallet. Bad idea. It really felt wrong once I lifted it up. It was like my back just, it didn't feel right. It's never quite felt as good since. I don't recommend it. The other thing, though, there was a guy in the gym, he had told me before I did that stupidity, he had told me about doing bench pressing for, I forget, I think he was trying for 7 something, you know, it's only 10 pounds more than what he'd done before bench pressing. And which was nowhere, you know, that's a lot. He's a big guy. He tore his pectoral muscle loose from the bone. Owie, owie. It just made me, oh, owie. Yeah, no, bad idea. Because the thing is, you just get to wanting to do more and more. So, you know, there's possibility I would have got to the point of doing something damaging to myself in the gym even too. I just happened to do it sort of at work. It was, yeah. They had a program where you could take home surplus stuff that was not needed anymore. And at that time I had a 6.2 pickup and they didn't need this 6.2 engine anymore. And the one thing which was the biggest interest why I wanted it was I knew they had just put a new fuel injection pump on it. So while the engine was questionable, the injection pump only had very little time on it. Was it worth it? No, not at all. And then actually that particular engine ended up getting stolen from me later. So I never even got to use it. Okay, sometimes you need a longer bit. Sometimes you weld them. The silver brazing works the best. You bore something out, give it another one, goes in here, a little bit of clearance. This particular one, I warmed each piece up, got the silver braze on each piece, heated it up again, put it together. Afterwards, I turned this down after putting it together. That's why it's not colored from being hot like that, because I wanted to make sure I had extra clearance for the bushings. We're going to another bushing there. And yeah, that's a reamer drill bit. The silver braze really works good for lengthening things like that because you don't get a lot of movement. You can weld them sometimes too, but there's a lot more pull and movement, just harder to keep everything straight. This right here, we're getting close to putting this in the block, and we have a little issue. We're getting a little bit dull on our reamer. It may still cut, but I'm going to hand dress it on the grinder, which you can get away with. I would have just put a new one in at this point, and I'm not against new reamers. If one of these is longer than another, and we're using this as on a normal reaming application where you're following a hole, it will make it pull a little bit, and then it will ream oversize. But since we're guiding it with the bushings, the bushing is actually guiding where it goes. It doesn't pull off center. So it doesn't get that pull for one being a little bit longer than the other that much. And the reason why I want to use this one instead of another one, this was the only one that I was able to buy when I bought the reamers for this job that was 1/1000 under the nominal metric size that I was going for. The other one I figured I would use if I needed to bring it to the size it's supposed to be, but this 1/1000 under is cutting the size so nice. The holes are a little on the tight side, but I'd rather have that than loose. So I just want to keep using it. So we can go ahead, come in here, and just cheat the dressing a little bit. Should have counted them first to know how many were there. We did one of these a while back too, where we took the whole reamer, we turned it down with CBN, and then we hand relieved the edge, trying to get the size that we wanted for a custom job. And it actually came out just right on. It cut the size we wanted it to. We had a little bit of wiggle room in there, but it's nice to have perfect ones. It's not essential. So now, come over here. We need this one. And depending on how nicely our hole drilled, sometimes these came right off, other times I've had to do a little bit of persuasion to get the block off because of the burr at the bottom of the hole. And then the reamer block, after we ream this, I will leave it on this whole fixture, take the whole fixture over to the bench and change it out there. And the reason why I do that at the bench, it has to go to the bench anyway, and I can just leave the reamer in it and then finish pulling the reamer straight on out instead of having to back it up to get it out. It's kind of interesting. I was thinking about something earlier. Younger guys, almost always, they go grab the impact wrench, they grab the whatever, and it is faster. It is. It's a little faster. Sometimes you strip threads by getting a little too much of a hurry getting started and pulling stuff when you wouldn't by hand. But it is faster. It really is. What I also noticed, though, is that the younger guys that always grab the impact never use both their hands for loosening a bolt. So there's a little bit of advantage to the old way. Now, am I going to do both at the same time? No. If I'm using an impact, I got one with the impact or thinking about picking it up. So it's two different ways. Okay, yep, that came right off. So it will go over here, getting ready to be installed again. This one comes back over here. But before we clean it off to go there, I'm going to blow off all of our stuff here. Feel for major burrs that might cause a problem. Techniques, blow chips off of the threads. Put them back. Blow out the holes just in case. Blow the whole surface out. Come over to where this is going to mount. Okay, and the actual surface that's going to touch is this one and this one. It kind of just goes in there. Pick it up a little bit. My thread started. Just enough to sort of hold it. Now, as I do these ones, again, don't want to be messing up threads. Once I mention something, I got to keep with it. Both hands, John, both hands. That one got tight. That's just wrench. At this point, we could use an impact, but you really don't want that impact right down at the end. You don't want it touching at this point yet. It's just a little bit much. So now I want to just little tension on these. And so we're pulling it in two directions. A little tension on these. Now we go to quite a bit of tension on these ones. Then we will tighten the big ones. Check these again. Okay. And I see I had forgotten to put my jack under here for when I was drilling, which is the bigger reason for the jack, more so than on the reaming. But I see I had forgotten to put it underneath the pad here. Kind of a good thing, but not making a lot of difference now that we're just taking the lighter reaming cut. Okay, now we will take our reamer out of here. And you see, you use a cheater for loosening these because you can't hurt it by loosening it too easy. Has nothing to do with the fact that I might have extremely tightened it last time. My friend was actually mentioning to me, where did I put the reamer?
Did we set it on the bench?
That's what I was guessing, yeah. And he was mentioning to me that he had actually taken one of these and in a shop and tightened it down, and it went to where it would not loosen afterwards. And he used a little bit of a cheater, but he didn't really pull on it hard, he said. Well, I've had them when they get old and bad. I've had them bind up even if you never used a cheater on them. Sometimes they just get bad and they don't move well anymore. Okay, now we go down. Coolant. And we're gonna drop our RPM a whole bunch. Yeah, do that. Okay. Had it on power feed there at first. I like the feel of it better for this. As long as it wants to move easy, I'm happy. If it doesn't, I want to wait for it to clear out. You still have a lot of reduction, so it's not very hard to turn. You have the hand wheel on here the same as you do on a lot of like your Bridgeport mills. You can kick them in and hand feed them through the power feed mechanism. The ideal for this reamer, cleaning these out, would be to have oil on this instead of the coolant. But I didn't want to make a mess here on the drill or set up on a different situation. Could have put a pan underneath it, put oil in it. I will try and get, if we get more of this job. We were supposed to be getting these on a regular basis. I was a little slow on getting these first ones done. We'll see if we get more of them to do or if they're annoyed at me. If we get more of them, I'll probably order another reamer that's 1,000ths under. This one I think I found surplus on eBay, where I shop for a lot of stuff, which is way quicker. I looked for one again the other day, didn't see any this size. Somebody's got something already made. It's just quicker than trying to find it, have it made. When we have our new big shop, everything's set up even better, then we can bring in our CNC tooling grinder, and we do all kinds of neat tools ourselves soon. Right now it just sits outside under cover. And no, we're not bragging about having one. It's a project. When it was shipped in here, the control got smashed in shipping. But it's almost just as well, because looking at the condition of it, while most of the machine looked pretty good, the control was a lot more dated and didn't look like it had had power on it as recently as the seller had claimed it had. I think there was some lying there. Bury your tools. Okay, so I will put that under there in case it decides to drop so it's not damaging the reamer. That's what that's there for. And we will unhook it there. This out of the way a little. Doesn't need to go all the way up. We can get it out the other way here. It's just fun. I like power clamp. Our other drill press that's outside, which we might never use, it's got hydraulic on it. It's a Fosdick. I really like the Fosdicks better, but it has two things about it. One, it's bigger than this one, so it doesn't fit in this spot, and two, it's worn out almost. It's functional, so it had to follow me home. I used it years ago. It went through a few hand exchanges before I got a hold of it, but $500, like I say, it followed me home. So that's it. That's all. We'll pull this off here with the crane. Wash it out. This one's done. We got one more to go. And then we can call the customer. And hopefully they'll be happy customers saying, thank you, thank you, thank you. Instead of, you're late. Let's see. Sometimes that happens.